When looking outward into deep space, the sheer scale of the cosmos is overwhelming. The universe expands into an endless void of stars. This is a picture of the observable universe, and looking at it asks a very direct question. Exactly how many galaxies are there? The immediate human instinct is to approach this like a simple inventory problem. We want to point a telescope at the dark patches, find the individual galaxies, and count them one by one. However, a physical count of them is completely impossible. There are just too many scattered across billions of light years for any manual census to succeed. Yet, despite that hard physical barrier, scientists have calculated a concrete, specific number. Our eyes provide only a narrow window into the cosmos. To account for the billions of galaxies beyond that window, we have to move from physical sight to mathematical deduction. The solution comes from the researchers and mathematicians inside human institutions like NASA. They operate within the bounds of the observable universe, a sphere of space defined by the age of the cosmos and the speed of light. It represents the limit of how far light has traveled to reach our telescopes. Even within this restricted area, the extreme distances and overlapping light make a true manual census mathematically unfeasible. Hitting this physical limit forces humanity to abandon brute force observation and rely on abstract logic. NASA shifts the strategy to estimation, applying the same statistical rigor used to calculate planetary masses or stellar lifespans. This diagram illustrates the first step, isolating a microscopic, seemingly empty slice of the night sky to act as a baseline sample. Telescopes focus on that tiny boundary for weeks, capturing enough light to reveal and tally every single faint source hidden in the dark. This leads to statistical extrapolation, the mathematical engine that allows researchers to map what they cannot see based on what they can. By taking the dense concentration of galaxies in that single sample, mathematicians multiply that density across the entire volume of the sky. This abstract mathematical process serves as the bedrock of decades of institutional space research. To ensure accuracy, this calculation factors in the massive, empty voids between galaxy clusters just as heavily as the dense regions. By trusting statistical modeling over raw visual observation, scientists transform an infinite void into a solvable equation. The result of that extrapolation equation gives us a concrete figure. Based on this monumental data, NASA has estimated there to be about 200 billion galaxies inside the observable universe. 200 billion. It is a number so large it initially feels just as overwhelming as staring into the empty night sky. Returning to this blue spiral, we now view it as one quantified piece of a larger solved equation. Every distant, blurry speck of light in this image is accounted for in the math, even if it has never been directly observed by a human eye. That 200 billion figure is a defining monument to human ingenuity and problem-solving. This estimate proves that while the universe remains too vast for our physical bodies to traverse, it is not too vast for human logic to measure.